So friends, good morning and welcome to the session on panel data. And I hope you are able to hear me clearly and my video, screen sharing, everything is fine. Anshika, is it fine? कोई
Yes,
प्रॉब्लम तो
sir.
नहीं कोई
No,
प्रॉब्लम
sir.
तो नहीं
No,
ओके
sir. No, sir.
ओके अंशिका जरा ध्यान से बैठना और सीखना
Ji, sir. Sure, sir.
ठीक है
Sir, we are
चलो
all there with you. Don't worry, sir.
but
Sir,
my
I
request
have
is
learned this topic from you only.
my request is concentrate.
Ji, sir. Thank you, sir.
Okay,
Okay,
good.
sir.
So today the day we have to learn how to handle complexities of the panel data, and that's a challenge for all of us. So let's start the day with God blessings, and hopefully we will have a wonderful day today, and God bless you. All the best to all of you. Have a lot of positive energy to begin with this particular session. So today the day of, I am saying optimism, day full of energy, day full of learning, and be energetic. And you have to have a lot of concentration in today's session. Okay, so all the best to all of you and have a wonderful learning in these sessions. So let's begin with some revisions of what we have discussed in earlier session. I'm not going to repeat everything, but what is important for today, only that thing I'm going to repeat. And the most important thing we have to understand is endogeneity versus exogeneity. Okay, endogeneity, remember, broadly refers to situations in which an explanatory variable, that is x, is correlated with the error term. So we find a correlation between the error term and the explanatory variable, and presence of that correlation leads to endogeneity problem. By endogeneity, we mean the correlation of the right-hand side regressors, x, and the disturbance term or the error term. That is covariance between x and the error term. If it is not zero, then we have a problem of endogeneity. And friends, by now, I hope you have a clear understanding about endogeneity, what it means, and what kind of problems it can create. Exogeneity means that each x variable does not depend upon the dependent variable y and thereby on the error term. So there is no correlation between error term and x. If the covariance between this is equal to 0, then we say we have exogeneity. Since y depends on error term, this means that x's are assumed to be independent of y, hence independent of error term. It is required because of the independent variables are not independent of error term and y, then estimated regression coefficients may not be unbiased, may not be consistent, and in some cases may not be efficient, and friends, OLS will fail to give you blue estimates. Regressors are said to be exogenous if they do not have endogeneity problem. It means that exogeneity among the explanatory variable will exist if there is no correlation between independent variable and error term. So given x, if the expectation of the error term is 0 for all I and t, then regressors x are strictly exogenous. So when I say for all I and t, that means I'm talking about all information related to past, present, and future. If it is so, then we say they are strictly exogenous. It means that at each period of time, The error term is uncorrelated with the regressors with all their lags and leads. That is to say, if the expectation of the error term product X for all S, look at this, 0, 1, 2, 3, and I'm saying plus, that means lead or future. Then we have a strict exogeneity. Okay, if the correlation does not exist for all legs, but this may not be zero for the future or the leads, you can say, then we have a weak exogeneity. Under weak exogeneity, the error term is unrelated only with the past values of X and not the future values of X. Exogeneity ensures that OLS estimates are blue, while endogeneity creates problem for OLS estimates and they are no longer remain blue. And please understand, exogeneity is your friend and gives you the blue OLS estimates. Endogeneity is a foe of OLS, does not help you in getting blue estimates. Okay. Right. So I hope you are able to understand till now what we have talked about endogeneity and exogeneity. Okay. Okay. So I didn't get any questions so far. If you have any questions, please shoot that question to me. So again, now note that why should we worry about endogeneity? Because endogeneity attacks our friend OLS and our estimates are no longer blue estimates. They may become biased, they may become inconsistent, and they may become inefficient as well. So be careful about your endogeneity issue. That's the foe, the enemy I'm saying. Strict exogeneity is required to obtain unbiased OLS estimates. Please understand that. If you don't have strict exogeneity, then you may not get unbiased OLS estimates. I'm not saying uh, you will get blue estimates. What I'm saying is you will get unbiased OLS estimators. Okay, please understand that. I'm not saying that OLS will give you uh, all properties of your estimators, but it will ensure definitely that your estimates will not be unbiased estimates. So that means throughout, we will be assuming that X and the error term, we have to assume that the covariance between X and the error term will be 0 for all values of X, whether you take past values, present values, or future values. Now let's also revise why do we have endogeneity problem? Endogeneity problem can be because of omitted variables, measurement error, simultaneity, and dynamic relationship. This, if you remember, omitted variable bias of a particular kind, that is unobserved unit related heterogeneity or unobserved cross-sectional heterogeneity, can be taken care of by your fixed effect estimator. Okay, but if you have a endogeneity problem because of this dynamic relationship, how you will take care of it? That's what we are going to discuss in these sessions, okay, on dynamic panel. Please understand, this can be taken care of by fixed effect. This can be taken care of by dynamic panel. And the method used for estimation of dynamic panel. Measurement error endogeneity, we are not going to address. To some extent, simultaneity will also be addressed in our dynamic relationship model. Okay, so please understand the agenda which we have. We are going to take care of cross-sectional unobserved heterogeneity by making use of fixed effect. Along with that, we also try to get endogeneity issues, are going to address endogeneity issues arising because of dynamic relations when we go for dynamic panel. Okay, so let's start with something more dynamic. And a quote before we go ahead: life is the dynamic, creative edge of reality. And lot of relationship you will find in economics and finance and accounting also, that the, we have dynamic relationship between the variables, and to capture it we are trying to learn how do we do that. Okay, I don't promise that literature has given you all solutions, but literature is evolving over a period of time and trying to give you better and better estimators so that you can take care of various indigeneity problems. So don't forget, keep strong yourself and finish what you have started 5 days ago. Okay, so be strong and put your best in learning. So taking you to the word of dynamic panel, and first let's try to understand what dynamic panel means. In a panel model, if we include in the specified module the lagged values of the dependent variable, then we have a dynamic panel. So if you have YIT and I say alpha plus beta YIT minus 1 and others, then presence of this lagged variable of dependent variable make your model a dynamic model, because it tells you how dynamically Y is changing from its past, how past is changing the future values of your Y. So that dynamic relationship, the relationship which is working over a period of time, can be captured through dynamic panel. In the dynamic panel, we add lag terms of the dependent variable as explanatory variables. Okay, so look at this, you have YT and you have lags of Y, and this shows that we have a dynamic panel because the relationship is determined dynamically. Okay, and friends, tell me what this term is. You must have talked about this term yesterday. It has a subscript I but does not have a subscript T. So friends, tell me what is it? Any one of you? Uh, Milith is asking me what panel means. I'm sorry, for the last 2 days we are talking about panel, so you must know that. Okay, and Mohammed Muhammad Imdadul is saying that this represents a unobserved cross-sectional heterogeneity. Yes, Shantanu Ghosh is saying, okay, that's correct. Fixed effect, yes. And I repeat, dynamic panel means dependent variable is also determined by its lags, or if lags of a dependent variable are coming in my list of independent variable, then dynamic panel exists. Okay, so friends, this can be taken care of. Endogeneity caused by UI, that can be taken care of by making use of a fixed effect. Okay, and I'm getting so many responses, and I'm happy that all of you were correct when you said that UI mu I represents cross-sectional unobserved heterogeneity. Okay, right? So keep this in mind. Maybe in future, I take it granted that you understand it. Now let's see what is the motivation behind using dynamic panel data. What for we should go for it? What's the motivation? Why should I use a dynamic panel? There should be a reason for using it. I can end my story by taking fixed effect and random effect, and there I stop my story. I don't go beyond it. I must have a reason why I'm interested in going to dynamic panel data analysis. Okay. One of the reason for using dynamic panel is underlying theory. For example, dividend decisions are normally dynamic in nature, as previous year dividend decision may affect this year decision along with other explanatory variables. Another example, inflation normally has some kind of a sustained process. That means inflation of period T may be a function of inflation of period T minus 1. If you get this kind of relationship according to the theory, then you have a motivation to use dynamic panel. Okay. Existing empirical literature, it may be possible that a theory may not exist, but existing empirical work done by different researchers may suggest a dynamic panel model. So, friends, these could be probable motivations for you to go for dynamic panel. Please use dynamic panel model only when we have reasons to use it. Otherwise, please don't use this. Just for the sake of dynamic panel, don't use it. Should be supported by underlying theory or by the literature. Before we proceed further, let's have a look at a quote that says, an honest enemy is always better than a friend who lies. And recall again and again, I'm saying OLS is the best friend, but you have to ensure that assumptions of OLS are satisfied. Otherwise, the error term, if you don't discipline the error term will start behaving in a very strange manner and start creating a lot of problem for us. And that's why we say error term is an enemy for us, a foe for us. But fortunately, that enemy is honest, and it reveals what you know, its true nature. So what will happen when you trust your frame overlay and apply the same in the dynamic panel data setting? The estimates become biased, inconsistent, or inefficient. Any one of you can give me the reason why? Indrajit is saying more than 1 lakh, and uh, it is primarily because we have a endogeneity problem. Error term of the previous period is impacting your YIT minus 1, and that's impacting your YIT, and that creates a endogeneity problem. Let me explain what I mean by this. YIT is equal to alpha plus beta YT minus 1 plus other things plus your error term. Okay, right. This is impacted by previous period error term. And if it is impacted by the previous period term, then it will be also affecting this. And if it is affecting it, then its effect will be indirectly merged into this, and that start creating a problem. Okay, then you will find endogeneity problem. Yeah, I repeat what I'm saying, and please try to understand it. This is an example of panel data because I'm using lagged variable of dependent variable. Okay, this, if you see y t minus 2 is equal to alpha plus beta, sorry, equal to y t minus 2 plus error term of the period I t minus 1. So this is impacting this, and this is impacting this, and that creates a problem. And that creates a endogeneity problem because this also started impacting it and impacting it, and you start getting correlations, and you start getting endogeneity problem. Hashim is asking, can we use dynamic panel in at a micro level? Yes, the whole corporate finance, if you see, is full of use application of dynamic panel. Isha is asking, can we go ahead with the dynamic panel if there is no indigeneity problem? But please understand, again, this is what I was explaining to you short while. That is, the moment you have a dynamic panel, indigeneity problem will definitely emerge, and you have to take care of it. You can't imagine dynamic panel without indigeneity problem. Uh, Simran, please understand the whole discussion is for short panels and not for long panels. Okay, so this, I think Ankit Singhal is asking me a question, how the past error is impacting my present variable. Look at this. This error term is impacting my estimate of this, yit, yit minus 2. There is a relationship you can see here, right? This I'm putting in my equation here, which is impacting this. So indirectly, you will find that this is impacting this. And that's where you will start getting a problem. Okay. Uh, Rashmi is saying that whenever you take legs of the variables, you will have endogeneity problem. You endogeneity problem will be there when you talk about legs of dependent variable and not legs of independent variable. Okay. Uh, Sunil Kumar is asking that if you take significance value of the betas, can we say that dynamic panel will not create a problem or will create a problem? That's not the issue. Please understand it. My submission to all of you is you must go for dynamic panel only when theory suggests that dynamic relationship or the literature suggests that dynamic relationship. Otherwise, you will be in trouble because dynamic panel data will always have a endogeneity problem. Palak, I'm not saying the future error term. What I'm saying, the past error term will impact today's error term. Okay, friends, let's go further. But the problem is with R4, the error term, which makes our OLS estimates unacceptable. Take care of the error term and its relation with other terms in the model. And that's the biggest challenge for all of us. And that's what you have to appreciate when we talk about dynamic panel. So what happens to the quality of our estimates when we ignore the dynamic panel structure? Please understand that. Dynamic panel structure is applicable and you ignore it. Okay. Then let's see what problem we will face. So ignoring, let's say case one, ignoring the dynamic panel data structure in the model. Assume that our true model is this. This is my true model, which is dynamic in nature. We ignore it and we go for it. What will happen? So when you go for it, then the estimates of the error term which you will get, let's call it mu it. This mu it, the estimated error term which you will get, will have this particular variable residing in, you know, in the error term. It will just go and sit in your estimated error term. Please understand that. Meshwar said he talking about partial autocorrelation. No. So can we take nav return as a dependent variable? Yes, you can take it. No problem in it. And I don't know, Pramod Lonkar is talking about inefficient estimates. What they mean by it? Murugan is asking what is efficient and consistent or, you know, uh, efficient, consistent estimator. Friends, I'm not going to repeat it because these are very basic questions. And we believe that when you start talking about time series and panel data, you must understand what is biasness, unbiasedness, consistent, efficiency, sufficiency. All those properties of the blue, you must understand it. Okay, let me repeat what I'm saying. True model is the dynamic model. That's my true model, right? That's my true model. I ignore it. Instead of it, I estimate this model. When I estimate it, the error term, which I give say new IT, then you will find this YIT, which is an omitted variable in my model, will sit here. And the moment it sits here, it start creating a problem. And therefore, if the true relationship is dynamic and you ignore it, your results will not be reliable results. Please understand it. The error term may have a serial correlation problem because this is correlated with the previous year and it may have a correlation problem. And it may also create a endogeneity problem. And your estimates will not be blue estimates. Please take care of it. Again, I'm saying you have to understand whether the model is dynamic or static through underlying theory or through literature. Okay. Considering the dynamic panel data in the structure, but ignoring the complications arising due to dynamic panel data structure. So for example, you have YT, IT is equal to alpha plus beta YT minus 1 plus other things. This is I have taken this dynamic model, but instead of using the methodology of dynamic panel data, I ignore it, I have estimates. Then again, friends, you will be in trouble. So consider the following dynamic panel model. This is what you have taken. We estimate the above one using, say, fixed effect estimator. In such a case, it can be shown that explanatory variable are correlated with error term, violating the assumption of strict exogeneity of FE estimator. And you can see here, error term of the previous period is having impact on y t minus 1, which is having impact on this, and this is what creates a problem because it will sit here indirectly if you don't take care of it, and then it started creating a problem. And this problem has been first time identified by nickel, and that is what is called a nickel bias. Understand that. I repeat two cases. One, dynamic panel structure is applicable and you have ignored it. You are in trouble. Second case, you have identified dynamic panel data structure, but you have not taken care of this structure. You are simply using FE estimates or RE estimates without caring for dynamic structure. Then again, you will be in trouble because your estimates will become biased estimates. And that kind of a bias is called a nickel bias. Okay, so I hope this discussion is clear to you. Uh, Pooja Khanna is asking, how do we know that fixed effect will have endogeneity problem? again, many of the time you will find you cannot prove statistically indigeneity problem, but logically, theoretically, you can show that indigeneity does exist in your estimation, and that what is creating a problem. Uh, Isha, I think you have to understand properly what is the meaning of autocorrelation. Autocorrelation talks about the autocorrelation of the error term only. But here we are talking about endogeneity problem. Endogeneity problem talks about correlation between dependent variable and error term. So when I say autocorrelation problem, that means error term of the previous period, error term of this period, correlation is not zero. Then we have a autocorrelation problem. But endogeneity problem is different when X is not correlated with the error term. Please appreciate this point. Isha, I think you will be able to get this. Okay, right. And let's see what it says. Nickel 1980 in his paper 1981 had shown that fixed effects estimator for the dynamic panel model are biased estimators. And even for very large sample of cross-sectional, these estimators are inconsistent. For t tending to infinity, this bias may disappear, but still you will get inconsistent results. But friends, we never get very large sample across time. We are not talking about the long panels, you're talking about short panels. And therefore, if you're working with the short panels and you ignore dynamic panel data structure, start using fixed effect estimator, then your estimates will be biased estimators. So therefore, there is a need to take care of it. Okay. If your n tends to infinity and t tends to infinity, friends, we have no method to estimate it because if you have infinite number of observations, you cannot have any estimation. You should have finite number of estimations, finite number of observations. Okay, both cannot be infinite. So the lesson is if the true model is dynamic panel model, then we should not ignore the dynamic structure of the model, otherwise we are in trouble. Even if we consider the dynamic panel model, then we should not use FE estimators blindly because that will lead to what I'm calling as a nickel bias. Okay. Shantanu, if you say that your dependent variable is time invariant, then it's like a cross-sectional data because it's not changing with the time. So it's a cross-sectional data. So if it is a cross-sectional data, then you use tools of cross-sectional data and not, you know, any other tool. Sunil, you use REFE, both cases, the result will not give you the best results. Somebody is asking, is indigeneity is what? covariance between x or the error term, or covariance between y and the error term. That's what we say when we talk about endogeneity. Indrajit is asking, can we use dynamic panel for the 4-5 years? You can make use of it, but the problem is that you may not be able to capture the true dynamic relationship. And I will also share with you another problem if you have a very few years observation. Okay, what is that problem that we will discuss later on? Palak Jain is asking me, how do we know whether results are coming to know it? The theory of econometric that tells us that if you go for it, then your results will be wrong results. And in those who have developed the theories, they have given the proof, but we are not going to talk about those proofs. And if you are interested in the original results, then you can go for the original articles, and you will get the proofs. So Nikhil in his article has given the proof why the biasness exists. Okay, N5T20, okay, no problem. Uh, Many times I find that a lot of questions are asking me what is ideal. Okay, and friends, there is no ideal thing in econometric methodology. It's comparatively better, or you can say it's good, or I can say this is performing better than the other. But what is the ideal? I cannot answer that question. You cannot ask me what should be the ideal R square, what should be the ideal adjusted R square. If you start asking me this question, my answer is sorry, I do not know what are the ideal things. Okay, right. Further, please note what will happen when you apply pooled OLS to a dynamic panel model. Estimates of the coefficients of the lag dependent variable will have upward bias. Understand that. Even parallel structure you are not applying, you're just having the pooled OLS, then your coefficients of the lag dependent variable will have an upward bias. And what will happen when you apply fixed effect model, while in fact true model is a dynamic panel setting, estimates of the coefficient of the lag dependent variable will have a downward bias. So both are creating problem. One is creating an upward bias, another is creating a downward bias. And both are not acceptable to us. And that's why the whole fight in the literature is how to get, the best estimator. And that process is still going on. People are working hard on it and trying to give you better and better and still better estimates. So lesson for us is improper use of model may result into biased, inconsistent, and inefficient estimates. So friends, be careful. It's a very strong message which I'm going to give all researchers, and I think Seema Gupta, Manoj Dash, Nidhi Dhamija, I think is there. They will all appreciate it that improper use of model in research is not appreciated at all, and you have to come out with a proper model. Okay. Right. So somebody is asking, how do we know upward or downward uh, bias? And that is being proved by the different researchers in their research articles. So I'm not going to talk about that. So again, I'm revisiting the Y endogeneity, this emoted variable bias, error term, simultaneity, and dynamic relationship. And that's what we are focusing throughout in our discussion. And don't forget, it's a source of endogeneity and it creates a problem. Okay. Manoj, again, lower R square or higher R square is a relative concept, and you have to take it accordingly. Say finance, if I'm working with the market data where my share prices are determined by hundreds of variables, and if one variable is capturing 10% of the variation, I will be very happy with it. Okay, right? So it's all relative, and you have to see the value of R square in the context of your research and take a call accordingly. Okay. So what is the problem created by dynamic panel data structure in estimation? Let's repeat it, because unless and until these things go deeper into your heart and mind, you cannot appreciate it, and you will not consciously use your models. Okay. So presence of dynamic panel data structure in our model creates a problem of endogeneity, and that makes our estimates are inconsistent, biased, or maybe sometime inefficient. So the challenge is how to take care of indigeneity and thereby, uh, you know, get consistent estimates. Okay. How to take care of this challenge? To take care of this indigeneity problem and thereby inconsistent estimators, one may use what is called instrumental variables. And you might be wondering what is this instrumental variable, and how they can take care of indigeneity problem and thereby the issues about OLS estimators. Okay. Sushita, Hosman Taylor test check for indigeneity of a very particular kind and not the kind of dynamic panel. So please don't use that test blindly. That you cannot use when you are having a dynamic panel data structure. Okay, any one of you can give me what we understand by instrumental variable, which are popularly symbolized by IV. Indrajit is saying close proxy. You're very near to this, but do you have any nature of this proxy? Certain conditions on that particular proxy? Right. Sunil is and other people are rightly saying instrumental variables, of course, is a proxy, but that proxy should have certain conditions. And now let's understand what is an instrumental variable or IV. A variable is said to be an instrumental variable if two conditions are satisfied. One, it is uncorrelated with error term. Suppose I say I is my instrumental variable, okay? Then covariance between this instrumental variable and the error term should be equal to 0. Okay, and that's what is called a exclusion condition or validity condition. So your instrumental variable will have exclusion property or will have a valid condition if it does not have any correlation with the error term. Second important condition is a relevance condition. So the moment you say it should be a proxy, that means I, which is being used as an instrument for a independent variable x, it should be correlated with x. It should not be equal to 0. So understand this. Covariance with the error term should be 0, but the covariance with the independent variable for which you are going to use your instrumental
Hello, no.
variable. Hello, who is there? And relevance condition says that the instrumental variable should be correlated with your independent variable for which you are going to use instrumental variable. Multicollinearity problem will not go because instead of x, I will be using I. X is creating endogeneity problem because x is correlated with the error term, but instrumental variable is not correlated with error term. So in place of x, I will start using I, which is my independent y, which is my instrumental variable. Uh, if so, multicollinearity problem will not arise. Yes, multicollinearity problem will not arise. Please, because I'm not using both together, x and I. I'm replacing x and using instrumental variable. Uh, Sunil Kumar is saying instead of instrumental variable can be used omitted variable. You can use it, but make sure that these two conditions are satisfied. And the moment these two conditions are satisfied, whatever name you want to give it, you can give it, but they will become finally instrumental variable. Herman, welcome for your comments. Hashim is asking me, how do we come to know about instrumental variable? Friends, that's a really fight and a lot of experimentation has to be done to come out with the instrumental variable. Not easy job to identify them. Okay. Harban, you are saying you take difference, start using lag of its variable uh, as an instrument variable. Of course, that we do, but I'm deferring discussion on it right now that we will talk about when we go for estimators for instrumental variable. But your observation is very valid and keep it up. Thank you. Uh, we will take an example of instrumental variable. And in fact, I've shared a database which I have data set which I've taken from his book. And in fact, that example, that data set is widely used by different people, even Gujarati, Woolrich. They have also shared the same, they have used the same data, of course, with some minor differences here and there. Okay, so in other words, a variable jet is an instrumental variable if Z is not correlated with the error term, and Z is correlated with your degrees of with your regressor. Sorry. Okay. So validity requirement says that the instrumental variable must not suffer from the same endogeneity problem as X is suffering. That means the correlation between that instrumental variable and the error term should be zero. The relevance requirement says that the instrumental variable must be closely correlated with X. Okay, so I hope you are able to appreciate the meaning of instrumental variable. So let us take a pause and meditate on what we have discussed and learned so far about dynamic pattern. Okay, and then in the meantime, I take some questions coming from you people. Okay, friends, let's go ahead and before I proceed further, let me summarize. In a panel model, if we include in the specification of the lagged values of the dependent variable,
So your
then the
voice
result,
is not audible.
my voice is not audible. Now, अब आ रही है आवाज?
So
Your voice is clear
very
audible, sir.
slow.
Hello?
Your voice is
Clear, sir. Your voice is audible.
This is good.
Okay,
Your
thank
voice is
you.
very clear, sir.
Thank you. Presence of the lag term in the model creates endogeneity problem. As a consequence, our estimates using pooled OLS or FE estimators will become biased and may become inconsistent and also may become inefficient. So what is the way out? Way out is make use of instrumental variables. So you will find that whatever methodologies or estimators have been developed for dynamic panel data, they are all making use of instrumental variables. And that's why we need to understand what is a instrumental variable. Recall that an instrumental variable is one if it is not correlated with error term and it is correlated with regressor X. Okay, and an illustrative example of the instrumental variable. Let's take an example from principles of econometrics, Hill, Griffiths, and Lim. Okay, data file I've already shared with you. Let's see how do we work on it. So please open up Stata. And open up the file which I have sent you. Okay, friends, let me show you the data we have with us. So we have educational data with us. Sorry. So we have education of the respondent, experience of the respondent, square of the experience term, and father's education, mother's education, log of wage. What is it that I will explain later on? Okay. So the problem is that do you think that wage of people is a function of experience and education level? That's the model which we are going to work. And experience was found that it has a quadratic relationship, and therefore we are taking experience square. So friends, I hope you are able to understand the data. Now let's run simple regression model, that is regress with education. L log of age is my dependent variable. Education, experience square, and these are the results which we get. Sorry. Okay. So you will find here education is having an impact on it, and significant impact on it. Okay. So I don't know. Just give me a minute. Okay, friends, there's some problem here. Okay, friends, I don't know what's happening to it. Okay, that's the result which we get. And now, how do we know that education is creating a problem here? Uh, okay, friends, education, experience square, right? And there is a question about x. I'm answering in general, and x square. If you have in a model both of them, will you face a problem of multicollinearity? That's the question which have been raised. Any one of you will like, anyone will give you an answer why there is a correlation problem or there is no multicollinearity problem. Nitya Chauhan is saying rightly, there is no multicollinearity problem, because when we talk about correlation, we talk about linear correlation, and these two variables are not linear. So theoretically, correlation between them, correlation between x and x square should be 0. So we don't face any multicollinearity problem. Okay, so I hope you are able to understand that. Uh, okay, so friends, so many questions why experience is square. Uh, People might have done when they have taken the relationship. So I'm not going into it because this is an example I've taken from textbook. And in that example, they have used experience square. And if you really want to go into it, then you can make graph and you see that there might be some linear or non-linear relationship. Okay. Another thing which you have to understand, when I go for instrumental variable IV, then we make use of a two-stage least square method. First stage, what we do is we estimate variable, say for example, education, by making use of instruments. So once we get that estimate in the second stage, we run regression on the basis of the estimates which we get from first stage. So you estimate first stage, once you get it, then you can go for the second stage, and that's how you can get an idea about, you can get the estimate, the true estimate between the variables. So friends, let's repeat this process again. So what is the instrument we are using? We are using, we believe that education of a person has a relation with log of wages and thereby with error term. Quite possible. But if I take mother income, mother education or father's education, then you will find they impact education of the child, but their education may not affect the wages of that particular respondent. So theoretically, we can say that we are able to identify an instrumental variable. It's all theory. I'm not going to prove anything here, right? Okay, so this model we are not going to accept in any case. So let's follow 2 SLS and then try to get the estimate of it. Okay, so in the first stage, regress, sorry, regress, education, experience, experience square, mothers, fathers, and get the estimates of it. And you will find, friends, that the mother education has an impact. Father education has an impact on a respondent. So that established that there is a high correlation between the education of the respondent with the education of father and mother. Whatever estimates we get out of it, let's store those estimates here and regress, sorry, estimate, let's call it y bar, comma, xp. This is the command that helps you in predicting and storing the value of the predicted variable or estimated variable, y bar. Okay. Uh, I think E stat y just let me see what was the command I was having here. Uh, Harman, क्या command थी? Any idea? I'm not able to recall that command. I think it's predict. Predict y bar, comma, xp. Yes, right. I'm sorry, I was using estat and all that, but it's a predict command that works. And you will see that there is a y bar here. Okay, so first step is over. We run education with this, and now let's go for second step. In the second step, I regress LWH with the y bar with the experience and experience square. Okay, sorry, experience square. Sorry. And that's what we get as a result. Uh, right. So now you see that education is coming to be significant at 0.6 level, and experience and experience square are coming to be significant, and that's what result we get. Earlier we were getting very significant impact of the education, but now it's not that significant. It's significant at 10% level, but the estimates of the coefficient which you get, they are unbiased and consistent and efficient estimates, and that's what you have to appreciate. Okay, another thing which you can do, instead of using one step, two step your own, you can use inbuilt function of stata, IVREG. instrumental variable regression, and you can work accordingly. I sorry I v rig. This is the command which can be used for instrumental variable. And then you have lwage as a dependent variable. Education, for education, we are going to use instrumental variable. So I'm not taking this. Then experience, then experience square. Then, sorry, you write bracket education equal to father education and mother education. So instrumentals have to be written within brackets, and whatever instrumental variables you want to use, that you write after the equal to sign. And now you will get the result. Krishan Kumar, see, if you take a correlation with the error term, I tell you, most of the time you will get that correlation 0, because OLS is based on that assumption. So that may not be the right way, but you can make use of uh, the theory or underlying logic behind that. Okay, so friends, look at this. The two-way step which we follow and the ivreg command which we have used, both are giving me the same results. You can check. So here the purpose of taking this particular example was to show you what I mean by instrumental variable and sorry. What instrumental variable means and how we can take care of them. And that's in the context of a cross-sectional data and not in the sense of, sorry. So let me repeat what we have done. Log of wages is this, and it was observed that independent variable education is creating endogeneity problem as it is correlated with the error term. And Mr. Krishan Kumar, if you run this regression, and I think I can show this because many of you have this problem. Right, sorry. So Mr. Krishan Kumar, let's see what we are doing in it. I'm just regressing LWH with education experience and error term. Okay. Then what I do is I predict, say, resid, which is residual, and save it in a variable which is called resid. If I calculate correlation between the resid and education, see what happens. It's coming to be 0. So friends, statistically, it is not possible for you to find out correlation between the error term and the independent variable which is creating problem. Because OLS, when you are using OLS presumes that there is no correlation and gives you the error terms accordingly. I think Mr. Krishan Kumar, that point is clear. Suppose is asking instrumental variable with yt minus 1. That discussion we will take after the break. Palak, two-stage results are same and not the one-stage results. Education is not a categorical variable. Education is a scale level variable, and you can see it from here. This is education is not the categorical variable. It is the scale level variable. Okay. So to implement instrumental variables, two-stage least square method is used. And first we have used mother's education and father's education, get an estimate of the education, plug it here, and that will take care of endogeneity problem. You can see the results now here. Coming to be significant, and then we run the model, we get this. Okay, so I hope you are able to understand this. Marvin is asking to find out the instrumental variable. Should we do experimentation or theory? Both are important, because it might be possible what is suggested in theory may not be applicable in the real life. So you have to experiment as well as take the help of the underlying theory and literature. And you can also make use of instrumental regression, IVGRS, 2SLS, dependent variable, and you get the result. Okay. And friend, this is optional. If you see, not necessary to write it, because I've not used it and still I was getting the result. It is presumed that we are using 2SLS. So 2SLS is an optional in the command. So hope that by now you get some idea about instrumental variable and their use and their implementation. Friends, in this session, we try to appreciate what problem we may face if we move to dynamic panel, and that endogeneity problem can be taken care of by instrumental variables. And what are those instrumental variables that we have understand, that we have understood, because instrumental variables are the variables which we are going to use in our discussion. So before we proceed further, any question, any doubt? Uh, Friends, we will be sharing with you the list of the books at the end of the next session. And how do we know whether the dynamic panels should be applied or not? Again, I repeat, use theory, underlying literature, and develop your model accordingly. Soumya Singhal is asking if R square is low, can we say there is indigeneity problem? No, R square has nothing to do with the indigeneity problem. Uh, Mediation moderation you can show in the models but not in the dynamic model. Okay, how many instrumental variables we have to use? For that we have a test. You can identify whether you are using too much of instrumental variable or too low instrumental variable. So that we are going to talk about in the next session. Nitya Chauhan is asking, how do we know which instrumental variable is a good variable? And the one who satisfies those two conditions, correlation should be as strong as possible. If the correlation is very, very high between the independent variable for which you are using instrumental variable and the instrumental variable, then I can say that instrument may be a good instrument. IV approach can be used in any of the data, but dynamic, to take care of it, we have to use instrumental variable. How many lakhs we should use in dynamic? That question we will take in the next session. Y bar, education bar, they are same, but I have estimated separately for illustration purposes. They are exactly same. These are the estimated value which we get from our regression model. Rashmi, again, the question is, theory will tell whether you have endogeneity issues or not. Pramod Lankar is asking me, can we do the same thing in EViews? You can do it, but you may not get that flexibility and versatility of using commands, etc. in EViews, which you can get in Stata. Okay, so friends, I think we have taken enough questions. What next? That we are going to talk about in the next session. Okay, so we will start at 12 o'clock. Okay,
Thank
Anshika?
you, sir.
Okay, sir.
Okay,
Okay, sir.
okay, thank you, sir. Thank you for this excellent
Okay.
session. You explained in very simple manner, sir. I am sure all the participants have taken note of
Purushottam,
your
good.
valuable,
Thank you. Purushottam,
your
thank you.
valuable inputs and will be considering in their
Okay,
research work
okay,
and
okay.
teachings.
Good, good,
We will
good.
resume our session at 12 o'clock.
Right.
So, thank you.
Thank you,
Thank you.
sir.
Thank
Thank
you,
you, sir.
Anshika.